Chapter 54 continued. Checking air-cooled condensers. Condensers capacity reduction. More liquid refrigerant present than normal. Normal airflow reduced. Above normal ambient temperature. Causes for excess head pressure. Excessive low suction pressure. Non-combustibles. Overcharged refrigerant. Reduced condenser heat exchange. Dirty coils. High ambient temperature. Reduce airflow. Here's an excellent picture of the condensing coil cleaning. Do you see where the technician is spraying from the inside out? Because remember, you have a lot of buildup on the outside of that coil. And if you spray off the outside of that coil, just pushing it in, you might not dislodge everything. It might get stuck inside that coil. So you always want to try to clean from the inside out, releasing the debris and particles to the outside. Safety. Whenever operating pressurized gas or liquid equipment, be certain to wear goggles. Some form of air protection is recommended when scrubbing or scraping surfaces that may chip or break off in pieces. Checking water-cooled condensers. Adjust water flow so temperature rise does not exceed 15 degrees Fahrenheit. Calculate head pressure. Test for leaks. Remove scale. Restriction problems. Restricted water flow. Excess water flow. Safety. When handling cleaners, be aware of any special labels or warnings. Some can be poisonous. Wear goggles, rubber gloves, and a rubber bib apron. Cleaning of the heat exchangers are normally handled by a licensed and insured hazardous waste contractor. Water flow problems. Restricted water flow, leaky valves, clogged screens, chattering valves, valves incorrectly adjusted, sediment bond valves, leaking bellows. Excess water flow. Water pressure too high, water valve leaking, water valve incorrectly adjusted, measuring using flow meter. Tracing water circuit troubles. Check tubing joints, close, then crack them open. Water inlet valve to let a small amount of water flow. Disconnect water tubing joints sequentially along the system. Check for water flow at each joint. Check water valve. Check condensing water tubes. Correct water hammer by adding a T-fitting. Checking liquid lines. In-line components can be a source of leaks or unintentional pressure drop. Components to inspect: hand shutoff valves, sight glass, moisture indicators, inlet screens, filter dryers, and solenoid valves. Check liquid lines continued. To check for unintentional pressure drops, perform a temperature survey. A measurable temperature difference between the inlet and the outlet of a component indicates a pressure drop. Make sure reducers, fittings have not been used. Check for temperature along the length of the line. Unintentional pressure drop. Here's the chart that's much better, or a picture that's much better viewed in your book than on this slide. TXV related causes of frost on evaporator or suction line. TXV needle leaking, a sensing bulb not properly attached, located, or insulated, debris or dirt stuck in a TXV, inlet screen clogged, superheat adjustment is too low, external equalizer may be added, repaired with incorrect thermal bulb charge, replace with correct size orifice. Related causes of a starved evaporator: clogging TXV inlet screen, loss of refrigerant from TXV sensing bulb, frozen moisture in TXV, wax from oil accumulating on TXV, needle stuck shut, and that's rare, under capacity valve orifice. Too much refrigerant flowing past the TXV, loosen connections between the sensing bulb and the suction line, warm airflow over the uninsulated sensing bulb, pressure drop in evaporator too great, TXV needle stuck open or unable to close firmly, undersized evaporator, thermal bulb has wrong charge, TXV orifice too large. Checking electronic expansion valves perform the same function as a TXV but operate with different components. EEV components: stepper motor, electronic temperature sensor, controller, pressure transducer, and that's optional. Servicing EEV: determine the problem if controller or valve, check manufacturer's troubleshooting code, check for moisture and contaminants. Here's a picture of the EEV components and its wiring. Again, this is something probably easier to see on your or in your book. Checking evaporator pressure regulators, EPRs. Observe evaporator cooling and temperature. Measure the pressure drop across the EPR. Measure the temperature drop across the EPR. Common problems: leaky valve, valve stuck shut, valve out of adjustment, frost accumulating on bellows, clogged inlet screen. Check hot gas valves. Identify the valve used to control hot gas flow. Understand how each valve operates. Recognize symptoms of the valve malfunction. Check the following: temperature at inlet and outlet, sticky valves, electric supply, defrost timer. Checking solenoid valves. Check troubles, electrical troubles, connections dirty or loose, coil open or shorted, refrigerant troubles, valve sticking, wrap gently on it to unstick, leaky needles and seats, replace valve. Clean the inside and outside, and if possible, always clean from the inside out. Proper amount of liquid refrigerant at the proper pressure. Efficient air or water flow. Leak proof, properly sized. Checking suction lines. Inspect components, hand shut-off valves, vibration absorbers, check valves, evaporator pressure regulators, filter dryers, accumulators, any joint or connection. Check suction line size, check suction line's pressure drop, check EPR pressure drop, should be 2 psi or less. This is our last slide. Please watch the videos that follow.